So last thing we are doing is this. How many of you revise this notes vectors? Raise your hands. After every class, I keep telling you this. Every class, you need to next day or on the other day, you can put your hands down. You need to take out the notes. When I say revise the notes, matlab kya karna hai? You take the question, take a rough paper, and try to resolve on it on your own. I'm telling you again, advanced crack karne ke liye, you need not be a super genius or super IQ, but you need to work every day consistently. I have seen the super genius kids doing nothing in life. था मेरे पास एक ऐसा 2 years back. I thought he will get 200 rank. आया था last में 17,000. Overconfident था. हो जाएगा मेरे साथ. It has nothing to do with your IQ. Will help you, but if you're not disciplined, it doesn't matter. If you're really aiming for a very good rank below 300, below 500, you need to be very disciplined and sincere. Even if you want to get a rank of 5,000, भी joke नहीं है boss. You guys are taking this really lightly. That is what happened in the exam. Nothing much. You thought school के exam जैसा school में 95, 96% आ गया ICSE में तो we will कुछ कर लेंगे. 4 people passed the exam. वो था catch. Let's start off. So this was a disc thing which we did last time. Now, for the disc thing, if you see, we took the element in circles. So how can they frame a question on this? Let me show you one. Let's say we have a non-uniform disk. So let's say we got a non-uniform disk like this, where the density sigma is called mass per unit area. What is the meaning of this? Example, if someone says sigma is 3 kg per meter square, meaning 1 meter square ka sheet has a mass of 3 kg. That is the meaning of it. The general thing which you study in school, right, is mass per unit volume. That is rho. So we have something like this called sigma. R is the radius. So I'll give you one example, then I'll ask you a question on this. Right? So here they are giving you the sigma mass per unit area. Sigma is given by sigma naught into x. X is the radial distance from center. X ka value lies between R and 0. Sigma naught is constant. The question is find the mass of the disk. Okay. Now, see this thing. If the disk was uniform, you could have simply said mass of the disk will be sigma into area. Isn't it? Mass per unit area into area will give you the mass of the disk. But the problem here is, if you look at the density here, sigma naught x, you know what is happening? Sigma is sigma naught x. At the center, x is 0, means there is no mass. As you're going out, it is little heavier. It is heavy. It is more heavy. It is even more heavy. So as you go away from the center, the disk is becoming heavy and more heavy. That is the meaning of sigma naught x. The farther you are from the center, the more denser the disk is. Meaning someone constructed disk, made of, maybe in the center it is thermocol. As you're going out, you have aluminum, then you have steel. So it is a variable disk. The density is changing. So basically, as the radius increases, as we go away from the center, right, density increases, therefore mass increases. So each ring does not have same mass. So basically density increases, so mass is variable. Please have a look at this page once. So we need to find the mass. So let me show you one question how to do, and then I'll give you one more like this. Is the data clear what I asked you? So we got a disk of radius r, sigma is mass per unit area. Right? What is mass per unit area? Example, if I say 3 kg per meter square, meaning 1 meter square ka area will have a mass of 3 kg. So here sigma is equal to sigma naught x, meaning as x is increasing, x is the distance from the center. So the more distance you travel from the center, the more denser the disk is. So we want to find the mass of such a disk. So this is little lighter, this is heavy. The big circle, big dot indicates it's more denser. All clear with this? Everyone got the scenario, the question? Ritu, clear na? Aryan, Mayuka? Shreyansh, need to adjust your cam, I can't see you. Abhinav, Arjun, clear?
Yes, sir.
Ronak, got this? Now, how do you find the mass of this? So for a disk, how is the element? At a distance x, take a small ring. Of thickness dx. So the element is a thin ring. Ring with thickness dx. Radius is x, thickness is dx. So if you take a scissor and cut it here, what you get is a rectangle whose radius length will be 2 pi x, the width will be dx. We have done this last time. So the area of the strip will be the length into breadth, 2 pi x into dx. Now the mass of the small ring, what is mass of the ring? Definition is sigma into area, isn't it? Definition is sigma into area will give you the mass. Now here, since dx is so small, actually even on the ring, right, the density is changing. But the dx is so small, we can assume sigma is constant for that small thickness. This is the whole point of integration, right? If you think about it, last class we did this thing. Do you remember how we found the area? We took such a small dx. You assumed almost the height was same for all these points, right? Isn't it? In reality, if you see now, even for this small part, the height is not same. The height is different for different pieces. But the dx is so small, you can assume the height is almost same. The same way, the dx is so small, you can assume the sigma is same. So we get dm is equal to sigma naught x into dA, which is 2 pi x into dx. So you want the total mass? So dm will be sigma naught x into area is 2 pi x dx. So the total mass of the disk will be integral mass of the rings. Maybe I'll show it on the next page, but please have a look at this page. I can write it here. So this is sigma naught x into area is 2 pi x into dx. So I just took this thing, du pi x dx, and I just substituted here. So mass of the disk will be, add all the small pieces. 2 pi sigma naught is constant, and you get x square dx. X ka limits are what? X is going from the center to the radius. That will be 2 pi sigma naught x cube by 3 x square dx ka integral, people. Hope everyone practice the integration. 2 pi sigma naught r cubed by 3. That is the mass of the disk. Check. So the whole idea in this problem, right, since every cross section has a different density, you cannot directly multiply sigma into pi r square because sigma is changing everywhere. So at a distance x, you take such a thin piece, you can assume almost the mass is same on that small disk. So you calculate the mass of the thin disk and then add the mass of all the thin rings, and add all the mass of the thin rings, you get a full disk. This is a very important idea. We're going to use the same idea for later on for a sphere, cone, different structures. Do have a look at this. Quite an important idea. You encounter this thing in center of mass, rotational mechanics, electrostatics, gravitation, magnetism, EMI. At least you will encounter them in 8 to 9 chapters. I'll just show you one problem where we did recently with your seniors. It's in a chapter called viscosity, where the question was something like this. We had a disk which is rotating and it is placed on a thin layer of fluid. So the disk will rotate and stop, right? So the integration, see, look at the elements. This is how we choose the elements. The formula is different though. Idea was the same, but yeah. So this is how we choose elements. We encountered this in a lot of chapters. That was one. Then centromaster, it was obvious actually. We choose elements, arcs, a lot of stuff you will see in multiple places. Have a look at this. Let me give an example. Let me give one more on this. You can try. Anyone confused with this, please ask. Oh, you can ask your doubts. Huh? Don't think like, oh, sir is angry, so shouldn't ask. Angry is on the exam. That has nothing to do with you learning and asking doubts. If I don't shout on you, who will shout on you? You guys will just chill out then. Please have a look at this. Your point is to learn. My job is to make sure you're learning. And your job is to learn. I know school jaisa nahi hai. It is little different. But be a little strict with yourself.
Sir, can you explain the DM and the mass of this part?
Yes, samajh mein aaya. This thing you got it.
Yes, sir.
So this is the mass of what? One ring, right? This is the mass of one ring, na? So the disk is made of what? The disk is made of multiple rings, isn't it? So what is the meaning of this symbol, right? Summation, right?
Yes, summation of all values that we take.
So when I put this integral dm means what? I'm adding all the mass of all the rings, na? So if I add the mass of all the rings, what will I get? Mass of the full disk. Is that making sense? Sure. So I got dm and then I wrote like this. I didn't go in a proper format. Sure. Should I explain that more?
So how do you apply the limits there?
Limits. Now, what are you taking? Ring, na? Where is the first ring?
We get X.
Center, na?
Center.
Where is the last ring?
At R.
So why limit 0 to R? You are adding all the rings from 0 to R. Isn't that the meaning of limits? Where did you start and where did you end? The disk starts from the center and ends on the corner. Sure. All clear with this? Let's say a problem based on this. Same question, I'll just change the numbers. So we got a disk. Sigma is equal to 2x plus 3. X is distance from center. X ka value lies between 3 to 0. So matlab radius is 3 meters. Find the mass of the disk. This is kg per meter square. You can just put down that sigma thing. I'll show you the previous page. You can use this as a reference. So everything will be same. Only this will change. Ye sigma change hoga. Entire process is same. Only that sigma ka thing will change. Try. I'll go 2-3 minutes. Some of you marked actually too many questions. When you are doubtful, you should not have marked questions. And multiple choice questions, some of you unnecessarily messed up. A, B, D is the answer. You got to win A and B. Just leave A and B. No, you get at least 2 marks. You mark the wrong options, you got a -1 for that. I know, first exam, you guys didn't plan for it properly. You should have just done the single choice and integers properly. 35 to aata tha.
So in multiple correct, only one can also be correct.
Can be correct. What is the problem?
Oh, I thought more than one.
That is your problem. You thought.
That's why I got confused.
It can be one or all right. Anything could be there. That's what I'm saying. You can't go and argue with the examiner. How can you give only one answer right? There, you can use this as a reference if you're still confused on how to get this thing. I don't know how they're conducting exams in your classes. Maybe they're keeping initially in the little easier side to keep you comfortable and happy. I'll not do that. Advanced matlab advanced only. Mains means it will be like okay, mains only. You guys need to raise to that level. That's what they do every year with the seniors also. Till December, January, they are very happy. They get very good marks. Papers are easy because the last fees installment is in January. Once the full fees is paid, then they slaughter from Feb. All of a sudden, people find, oh, it has become difficult. Let's not be fooled. Let's work on this. Answers, anyone. You can got an answer, you should definitely type. That is how I know you're trying. It's okay. Even if it's wrong, that is okay. Just type. Try. I'll give you a minute more. We have some pretty good results and questions today. There are some integration results which you need to remember. 162 pi. Someone got 63 pi. Other answers. Yasha, Swastika, Ronak answers. Venkatesh, Shihan, Niranjan, Mayuka, Arjun answers. You should type. You have 2 answers. 162 pi, 63 pi. Wow. Both are quite weird though. One of you is definitely wrong. So how do you choose an element? At a distance x, take a ring, dx. Now, if you didn't get a question in the class, that is totally acceptable. But after the class gets over, next day you need to sit with the paper and resolve them. If you don't do that, no, that is wrong from your side. 63 pi, we have 2 people with 63 pi. Yeah, Aisha also 63. Malika, I think you are wrong. Check it out. So the area of the ring, dA is the area of ring, is 2 pi x into dx, standard stuff. Then the circumference into thickness. dm is mass of the ring, is sigma into area, which is 2x plus 3 into 2 pi x into dx. 2 pi 2x square plus 3x into dx. So mass of the disk is the mass of the rings. That's the meaning of integral. Add all of them. 2 pi is constant, that will come out to the integral. 2x square dx plus 3x dx integral. X ka value will go from 0 to 3, radius basically. This is x power n ka integration, people. X power n ka integration is x power n plus 1 by n plus 1. 2 pi, this is 2 into x power 2 plus 1, 3 by 3 plus this is 3 into x power 1 dx, x square by 2 Limits are 0 to 3. Limits are 0 to 3. So this will be 2 pi into 2. Put 3 there. That will be 3 cubed by 3. That will be 9. Plus 3 into 3 square. That is also 9 by 2. That is 9 2 is 18. 18 plus 27 by 2. 18 2 is 36. 36 27 63 by 2. 2 pi into 63 by 2. 2 cancels off 63 pi. Check it out. So the answer is mass is 63 pi kgs. Three into 9 by 2. 0 is anyway 0, so I'm not keeping that. So when I keep 3 here, and I have to put 0 and subtract. Please check the steps. I have a habit of skipping calculations. Calculations is your job. But still confused, please ask. Don't hesitate. But you need to learn how to do calculations fast. Vidyut, Venkatesh, Yasha, Aditya, you all got it right. Others, please see where it went wrong. Now, Ronak, clear with this? Swastika, Niranjan, Abhinav, Aryan, Ritu, clear? Maulika, Mayuka, you're there. Mayuka, clear, na? Someone missed. Any doubts on this? Please ask me. Can I turn the page?
Yes.
Turn the page. Next thing, sphere. So when you have a sphere, you can choose elements in two ways. Spheres are a little special in that way. Solid sphere. Radius are, you can choose elements thin hollow shells. Means you can treat them like, a small shell, small shell, small shell, small shell. Think of like this, onion ka layers. Ever peeled an onion? You will see onion ka layer upon layer, layer upon layer. So you can make a sphere like that. You can put, ek shell, thin layers, and we can make a full solid sphere. Or you can take elements as thin discs. So like this, you're making thin discs. So each disc radius will be different. So depending on the kind of configuration, you can get any configuration. You get the same answer. I'll show you when to use which. So whenever you take a solid sphere, the elements you have to take is either you can take hollow shells or you can take thin discs. Clear? Now let me show you how to use this. We will find volume of a sphere. We know the result. But like I said, no one will ask you that. So we have a sphere of radius r. It also looks like a disk only because we can't draw a 3D figure on a paper. So at distance x, take a thin shell of thickness dx. So what you have is a thin shell. So the volume of a thin shell will be surface area into thickness. Does that make sense, everyone? You can take the surface area into thickness will give you volume. So the small volume dV, what is the surface area of a sphere? Surface area of a sphere,
4 pi r square.
4 pi x r square. Right, and thickness is how much? Dx. So this is the volume of a thin shell. So if you want the volume of a full sphere, you just need to add the volume of all these thin shells. So this will be integral 4 pi x square dx. The first shell will start at the center, x is equal to 0. The last shell will start at the outside r. So we get 4 pi integral x square dx, limits from 0 to r. Remember I told you integration is actually easy. It is just x power n ka integration. The headache is creating the elements x cubed by 3, limit 0 to r. Substitute r, substitute 0. When you put 0, you get 0 anyway. 4 pi by 3 r cube. That's the volume of a sphere.
Yeah, but then why hollow sphere? Like it wouldn't, the volume wouldn't make a difference, right?
Meaning,
Like
you have to take a hollow sphere with a thin thickness. You have to put the thickness.
Oh, correct.
It's like I said, no onion. If you see how it looks, that thin layers, right? The thin
Yeah.
thicknesses you need. If you don't have the thin thickness, how will you get a volume? No? These are thin shells. They have small thickness. All clear with this? Please see how we took an element. So for a disk, the element is thin rings with dx thickness. For spheres, it is a thin shell, like an onion ka shell with small thickness dx. These questions, you should have seen them once. It doesn't generally click on the first attempt. But in physics, luckily, right, we have around 4 to 5 shapes, and these are the general things. No matter which chapter you see, these are the general things which will keep coming. So you should be quite comfortable with them. You'll get used to it as time passes. Clear? Let's see a question.
So can you go back for a moment?
Yeah.
Yes, sir, thank you.
Non-uniform sphere. Matlab sphere ka density is not constant. So we got a sphere. Rho is equal to rho naught x. Rho is the volume density, that is mass per unit volume. This is the density you studied in school. So in physics, we have 3 types of density: linear density, mass per unit length, mass per unit area, mass per unit volume. Rho naught is constant, x is the distance from center. Means as you go away from the center, the sphere is becoming heavier and heavier. Just like the disk problem. But in this case, it's a 3-dimensional structure. Find the mass of the sphere. Now, if you see, the problems have some resemblance, but they're not the exact same thing. So every time you won't learn new things. You will learn something which will look like some other problem, but it's not the same thing. You need to understand way to do that adjustment.
So what's the
Try this.
difference between a hollow sphere and a non-uniform sphere?
A hollow sphere is what? Hollow inside.
Yeah.
What is non-uniform sphere? Solid sphere, na?
Okay.
Meaning inside there is a material, but it is not uniform. Ever eaten Kinder Joy? Kinder Joy is a non-uniform sphere. Different layers. It's not a uniform thing. How do you do this thing? So basically here what is happening, center mein there is no mass, x is 0. As you go out, it is becoming heavier, more heavy and more heavy. It's becoming denser as we go out. Get it. Shreyans answers, Venkatesh, Arjun, Ronak answers. Everyone should try. Anytime you feel like exam ka question where there is some error, you can always post it and leave it. I'll do the corrections before posting the results.
Sir,
I think no one then. Haan, Palak.
sir, rho is the density, right?
Rho is the volume density, yeah. Mass per unit volume. Rho is rho naught into x. Rho naught is some constant and x is the distance from the center. Anyone confused with the question? Anything not clear? Please ask. If everything is clear, try. I'll give you another minute. There's a lot of similarity between this and the disk. Only thing, disk mein you used to take rings. In solid sphere, we take hollow shells with small thickness. Radius. They said na x is up to r. Take it na, radius is r. Divided by 3, 4 pi r cube. I'm not understanding what answers you guys are typing. Aditya, you just typed pi as an answer. Pi rho naught r power 4. Okay, Venkatesh says r power 4. Niranjan also. Niranjan, you got r cube.
Sir, I mistyped. It's R power 4.
How do you choose an element?
Sir, can you show the question again? Yes, sir.
So dx. So this is a small thin shell. This is volume of thin shell, which is nothing but the surface area 4 pi x square into thickness dx. dm is the mass of the thin shell. What is the mass? Density. This is rho is mass per volume. Will be density into volume. But what is density? Rho naught into x. What is volume? 4 pi x square into dx. So 4 pi rho naught x cube dx. Integrate. So you want the mass of the sphere, you have to add all these small masses dm. So that will be 4 pi rho naught integral x cube dx. X ka value goes from 0 to r because the inner shell starts from 0, outer shell is from r. 4 pi rho naught. This is x power 4 by 4. Limits will go from 0 to r. The 4 will cancel. You end up with pi rho naught r power 4. When you put 0, you get 0. So we are not considering the second term anyway. Please check. Sigma pi r power. Okay, you meant say rho naught, I guess, Ronak. Yeah. Ranjan, you got it right. Aditya got it right. Venkatesh got it right. Yep. 4 people got it right. Others, please check. Confused, please ask me. So you always have to see what is given. Rho is mass by volume, na? So you have to multiply rho into volume of the thin shell. Then you'll get the mass of the thin shell. If you integrate the thin shell, you'll get full sphere. That's the whole point. If you see, the story is always the same. Do have a look at this. Please ask me if you're confused. Clear? Next one. Can I turn the page? This is still a standard question. It's a good one. Now, the actual question. See. Now, if they really want to kind of, I won't say torture you, but yeah, they want to ask you. Let's see a question how they'll frame. This is important. So R is radius. Someone filled the shell with some water up to height h. You're getting it is not fully filled. It is partially filled. This is the radius R. That is height h from the bottom. Find the volume of the water. A hollow shell is partially filled with liquid. Up to height h as shown. It is not fully filled. Fully filled, you know the answer. Find the volume of the liquid. I hope the question was clear. Why does it matter? Shell is uniform or not, Malika? It's just an empty shell, na? Hollow shell. Inside the hollow shell, you poured liquid. So how much liquid is there? Understood, no? It's like, think like this. There is a small ball, plastic ball with a hole. You poured liquid inside. Got it? So how much liquid is there if the height is only h? Got it? It has not. I'm not asking you mass of the shell. I'm asking mass of this liquid. So this red color thing is the liquid. So what is the volume of the red color liquid? The shaded. How do you do this? This is the hint. You have to take discs because you can't take shells here. It doesn't make sense. Think. I give 2-3 minutes about it. Think about it. See, when I say think, right, I don't mean you need to get the answer. It is okay. I don't care if you don't get an answer. But use the 2-3 minutes to really think like, okay, this can happen. This also can happen. Because exam mein yahi hoga, advance mein. They'll give you something totally, which will just knock you out of the boundary. It's like, what the hell karke? There are at least in advance out of 100%, 30% papers like that. So you should be ready for that unknown things. And advance is like, in that they're specialized, they'll ask you something totally new concept, which is not there in the portion. They expect you to understand that in 10 minutes and answer questions. They do that. So think about it. It is okay if you don't get the answer. I don't care about that. I really want you to try. Think for a minute, then I'll ask you something else. We will discuss. Anyone confused with the question, please ask. Adrit, I can't see you. Yeah, you're there. Shreyansh, you need to do something about your cam next class at least, okay? From Amazon, you'll get a cam. Buy it. I don't care. You can put it on a laptop, a mobile cam. Make sure I can see you from next class. I want to see full face. Try. Now, let's say if this question comes in the exam. Now, this is one more thing. Just because you're very good with the subject doesn't mean you will get good marks in the exam, right? So this is one thing you need to know. So if this comes in the exam, how will you guess? There will be 4 options. Now I won't give you the options. So what will you do to eliminate options? So when I say guessing, right, I'll tell you one thing. Guessing requires more knowledge. So when your subject is very good, you'll reach a point where you'll see the question and you get a feel like, oh, aisa bhi kar sakta hu. Oh, okay, aisa bhi hota hai. In an exam like mains and bits, you'll be able to guess at least in a paper of 25, 3 to 4 questions you can guess. Advanced paper may maybe you can eliminate 2 options, but difficult to guess. 4 pi r minus h cube by 3. No. Suppose if I have to guess this, how will I guess? Anyone can tell me that? Because the end of the day, exam mein what matters is, did you get the answer or not? No one cares how you got it. If you can eliminate 3 options and got the answer, you should mark it and come. Once you are in the exam, the only thought process is how to get a right answer. I don't care how you got it. You guess it, you do some magic, doesn't matter. Once the exam is over, the only thing that matters is subject, not answer. People who don't understand this, they'll mess up the exams. Subject is very important outside the exam. Once you're in the exam, only marks matter. How you got the answer, no one cares. Subject is a way to get that answer, but it is different. Any guesses? I really want you to try and tell me someone guesses. If this question comes in the exam and there are 4 options, how will you eliminate them? And I'm not joking, this is a very serious thing I'm asking you. Because exam, you will be able to get answers like this. How will you guess this question? Anyone, you can say anything you think if you have an answer. Please don't hesitate, you can answer. No, really feeling shy, you can personally message me. But I would strongly recommend just unmute and just say something. If you hesitate here in such a small group where I not going to shout if you tell wrong answers. आगे जाके future में you will have to participate in front of hundreds of people. Here, Ronak, any guesses? Adrit, Aditya, Mayuka, Ritu, Maulika, Yash, Yasha, Swastika. Any guesses? How do you guess? Sure, I'll tell you one thing.
It has to be less than the volume of the roller sphere.
ठीक है, but that really won't help you much. Most of the time, all 4 options will be that. For example, if I keep h is equal to 2r, what should I get the answer? If h is equal to 2r means what?
We get the entire sphere.
Meaning the liquid is full, na? So if I keep h is equal to 2r in the options, answer क्या आना चाहिए? What should be the answer? If I keep h is equal to 2r, if I substitute h is equal to 2r in the options, what should I get the answer?
The volume.
4 by 3
4 by
pi r
3
cube,
pi r
na? So whoever does not give you 4 pi 3 pi r cube is wrong, right? Are you getting the logic? If I keep h is equal to 2r, I should get 4 by 3 pi r cube. Whoever doesn't give me that is wrong. Are you getting how to guess? This is how you guess. You don't guess by inky pinky ponky, father is that. वो guessing नहीं है. Head and tail, inky pinky ponky, वो guessing नहीं होता है. चलो, you did this and you eliminated 2 options. अभी भी B and D बच गया. What else can I do? I eliminated 2 options. What else can I do? How can I guess more?
We can guess the area of a disk.
Nah, re. We are putting h ka values and checking. Na, what else? What other value can I keep? Which I know the answer. If I keep h is equal to r,
Right, H equal to R.
h is equal to r is what?
hemisphere.
Half shell ना, तो वॉल्यूम कितना आना चाहिए?
2 by
2
3
by 3 pi r cube, right?
pi r cube.
Are you getting it? Half the volume, right? So if you put h is equal to r, the option should give you 2 by 3 pi r cube. If that doesn't give you, it is wrong. I hope you're getting how to guess. This is one way to guess by putting different values, and you're actually converting, you're changing the question. You're changing the question to something which you already know. You can also guess by dimensions. That is a different type of questions. Sometimes you can guess the questions by finding range of values. So there are multiple ways you can guess a question. So as time comes, I will teach you. But this is one way to guess. But how to solve? Let's see that. Listen. So from here, at a depth y, let me just so from here at a depth y, let's choose a thin disk. Okay. In the direction of y, you have to take a small height dy. Remember this thing. If you're taking x, it should be dx. If you're taking y, it should be dy. What is the meaning of dy? In the direction of y, you're taking a small dy, isn't it? That is the meaning of it. This is radius r. This is x. Pythagoras theorem. X square plus y square is equal to r square. Next thing, this thin disk which we got, the radius is x, the thickness is dy. It looks like a small cylinder, right? It looks like a small cylinder of height y and thickness dx. What is the volume of this small cylinder? Area into height.
Area and the thickness.
Thickness or height, same thing. Area will be pi x square into dy. Please check. Check till here what it did. So I cut a small slice. Are you getting how did I cut the slice? Imagine like this. Imagine you have a watermelon. If you take a knife and cut it like this, horizontally, what kind of shape will you get? एक ऐसा disc आएगा ना, with the red color part in the middle. Able to visualize how it is? If you take a watermelon and cut it horizontally 2 times, you will get a thin disc of watermelon. बीच में red color part होगा. Please have a look at this. What are the limits here? Y is going from where to where? Anyone?
0 to x.
Nah, be careful here. Y is the
0 to
height
x.
from here. Here y is how much? 0. What is y here?
R minus h.
R minus h. What is y here? R, na? So the limits will go from where to where? Where is the water starting and where is the water ending? Water is starting from R minus h to R, right? Please check this page. This is the basic idea of this. Any doubts on this page? Please ask. All clear with this? Do have a look at each step that I did. Confused anywhere, please ask. Anyone not convinced, not clear, didn't get it, please ask. Please don't hesitate. Get it cleared. Arjun, clear na? Malika? Clear? Ritu? Swastika, clear na? Abhinav? Shreyansh? Clear? Venkatesh? Ronak? Got this? Rehan? Perfect. Can I go ahead? So we got that small volume is pi into x square into dy. But what is x square? R square minus y square. Substitute here. So I want to bring everything in terms of y only, one coordinate. So the volume of that liquid will be integral dv, which is pi into integral r square dy minus y square dy. Y ka limits will be, look at this thing, the water is starting from r minus h, water is ending at r, because y is the distance from the center to the liquid surface. Y is the distance from center to the disk. So the first disk will occur at r minus h and the last disk will occur at r. So limits will go from y is equal to r minus h to y is equal to r. Please check the limits. If you see, integration is actually easy. Pi r square y dy ka integration minus y cube by 3 limits r minus h to r. Getting the element is the headache. एक बार element आ गया ना, it is simply x power n का integration. So we need to substitute the values here. This is pi r square. So how you put the limits? Put r minus h and then subtract them. R minus h minus r cube minus r minus h whole cube by 3. Please check what I did. I kept the upper limit, I kept the lower limit, and I subtracted them. If that is by chance getting confusing, I'll just do one thing. Pi, first put r square into r minus r cube by 3. Then put r minus h. R square into r minus h minus r minus h cube by 3. Simplify this. This will be pi r cube minus r cube by 3. That will be 2r cube by 3. Minus this will be r cube minus r square h minus r minus h whole cube. Can I simplify this further? This will become how much? Expand this. R cube minus 3r square h plus 3r h square minus h cube by 3.
So once can you go back? Okay, sir.
Getting it now, it is just a matter of actually simplifying. There is physics got over long back. Physics got over when you wrote the statement. So let me simplify it for you because the answer looks little decent. It looks dangerous, boss. Yeah, this is boring, na? ठीक है, कुछ नहीं कर सकते. 2r cube by 3 minus r cube plus r square h minus r cube by 3 minus will be plus 3 will cancel, r square h minus r h square plus h cube by 3 r h square could have simplified it in an easier way. Kya?
So you could have taken that r minus
R minus
common,
Q.
I could have taken r minus
h common in the second step.
that would have made your life easy actually. This is 2r cubed by 3 minus, if you have taken r minus h common, that would be better.
Yeah.
R square minus r minus h whole square by 3. That will be more easy to simplify. So this is 2r cubed by 3 minus r minus h. That would be 3r square minus r square minus h square plus 2r h. By 3. This is boring, right? So that will be 2r square minus h 2r h. I'm tired. I do remember the answer though. So you'll simplify this, you end up with simply 1 by 3 pi, yeah, pi h square into 3r minus h. I remember something like this. That will be what you'll get the answer finally. You can simplify. Actually, this will get cancelled.
So instead of
3r square, it will get cancelled. 3r square by 3. This term and this term will actually cancel off.
so we could simplify it by simply putting the value of h in the initial equation because the r and r terms would already get cancelled. So it
Where
is.
you're saying?
So instead of doing all this, we just put the value of h and get the answer pi r square h minus. No, in the integration part. We just put the value of h because the r terms will get cancelled. Since
Where
it is
you're
r
saying?
into some, in the integration pi into r
Limits
square.
you're saying?
Yeah, no, in the limits, instead of doing all this, we can observe that the r terms will get cancelled because it is r into something minus r minus h into the same thing. And the answer remaining would be h into all this, y ka value h.
I got what you're saying. You're saying, I'm not, maybe you're saying take y from the bottom.
No. The entire thing same, but in simpler calculations. No need to do all
Okay,
this.
you're guessing, yeah? You're saying it might cancel out करके बोल रहे हो?
No, I'm not guessing. The limits are r and r minus h.
Yeah, right,
So
agreed.
r and r will get cancelled, right? Because
No. Here it will get cancelled. Here it won't get cancelled. It's a cube function.
no, not like that. When we put the values and then eventually
Okay.
simplify, the r and r terms will obviously get cancelled.
And
And
that's
only
what I'm
the minus h.
what you're saying now, that is true for y power 1. Y cube ke liye not true. For y power 1, you'll put r minus h. Na? R will cancel.
But
For
I
y
got the
cube, you're
same
keeping
answer.
r cube. Maybe you're lucky there. How will you cancel r and r ka term here? You getting my point?
Okay.
That you can't cancel, na? You got the answer. You're lucky. All got this? Actually, I should have taken limits in another way. That would have made our life easy. You know how? Instead of taking y from the top, na, I should have taken y from the bottom.
That's what.
नहीं फिर भी उसमें भी goof up होगा. Then you know what will happen? This will be r minus y, na? Then it will be r square minus r minus y all square. Your life will still be bad. That will be simplified. This equation will get messed up. But this thing, chalo, we did so far to solve कर लेते हैं अभी. Let's not be lazy. This is pi 2r cubed by 3. Shit, I really hate this. R minus h into 3r square. So that is 2r square minus h square plus 2r h by 3. So basically this 2r square by 3 and this 2r cubed by 3 will cancel because of this r. And you're left with pi into minus of r minus h minus h square plus 2r h by 3. So this will be pi into r minus h into, take out one h common, you end up with h minus 2r by नहीं कैंसिल नहीं होगा ऐसा. because this h into 2r square term will be left over. Shit. Okay. So therefore, we know the answer. We will solve it. I will leave it to you guys. Let's not waste time. So the answer is 1 by 3 pi. I would have solved it, but I'm getting bored. 1 by 3 pi h square into 3r minus h. The answer is a good answer. Simplify, you will get this. Okay? It is just max there. But Ronnie got the same answer. Interesting. But everyone got the steps? Anyone didn't get the steps, please ask me. Calculations, I will leave it to you. Simplify this and just prove it is the answer. If you see, answer is really not that bad. Clear? Next one. Next one. So I'll write the result here. 1 by 3 pi h square r minus 3r minus h. Useful result. Next one is pretty good one, right? This will come in at least 4 chapters. Let's say this is a part of a sphere. It's not a complete hemisphere, it's a part of a sphere. This is a part of a hollow sphere. Means, you know how it is? You have a full sphere, someone took a scissors and cut it here. So when you cut this, this is theta. Able to visualize how it is? You take a full sphere and cut it, not at the center, cut it little to the side. Then you get a part of a sphere, no? So basically it is like this. So someone just cut it like this. That this is the shaded part. Understood the diagram? Find the surface area of this sphere. Find the surface area of the shaded part. We will encounter this in friction. That's the 3rd or 4th chapter. Optics, electrostatics, modern physics. 4 chapters you will encounter this. If this comes in the exam, how will you guess? If this comes in the exam, how will you guess? Anyone?
If we
Input
put the
values and see
theta
what
as 180, then we should get the whole square.
Theta is 180, meaning it is full sphere ho jayega na?
Yes.
Then you should get how much, Aisha?
Then we'll get the full surface area of the.
How much? How much is that? Full sphere. 4 pi r square, na?
Yes.
Anything else can we put?
90 degree to get all.
90, na? If you put theta 90, you'll get a half sphere. There are 2 ways you can guess this from options. Let's calculate this. Think. How will you choose an element? It's a pretty interesting idea, though. I hope the question was clear. Someone didn't get the diagram, please ask. Today's class is quite an important class. Make sure to do all these problems again. You should get used to this kind of shapes. If you actually observe, the integration terms are actually easy. The headache is getting till that integration. How will you choose an element here?
Sir, we
Listen.
take the integration of pi r square d cos theta, and the limits will be theta belongs to theta to 0, 0 to theta.
Let's see. See what you're doing now. From here, at an angle alpha, you take a small angle d alpha. You take a small strip here, right? Which will be r d alpha, the small arc. R is the radius of the thing. This is the center. So from here, you are taking an element like this. I'm unable to draw this properly. There. You're getting how is the element? It's a ring. So if you just remove this element here, this is how it looks. Are you able to visualize the strip? If you cut that thin strip, you get a hollow circle there with a thin thickness, where this thickness will be r into d alpha, arc length. This radius will be r sine alpha, opposite side. Because if this length is r, this is alpha, this height will be r sine alpha, opposite side. Is that clear, everyone? Again, how did I get the strip? Imagine a watermelon, cut it like this. You will get a disc. Remove the red color part inside, remove that. What do you get? You get a green color band, Are you able to visualize? Take a watermelon, cut it in the horizontal, you'll get a disc. बीच में red part जो है ना वो निकाल देना. What do you get? A green color band, isn't it? Is that clear? Now take a scissor and cut it. When you cut this, it will become like this, where this circumference will be 2 pi r sine alpha, the length. The width will be r d alpha. It becomes a rectangle. Now, what is the area of this small strip? Length into breadth. 2 pi r sine alpha into r d alpha. This is area, surface area of the thin strip. Please check this thing, how I took the element. The idea of taking an element is quite important. We will see this a lot. Meaning recently, I'll show you how we used it. There, this was a question actually. There is a shell, part of a shell. So there is some charge and all blah, blah, blah. The question was find the field. See how we took the element. Exact same way. So we choose an element like that. You take at an angle alpha, take a small thickness and you'll get this. This is an electrostatics. Center of mass. Here, exact same question. Part of a hollow sphere. You choose an element. Friction. You will keep encountering this. Part of a sphere. quite an important result. You need to mug up the final result, but you should know how to do it also, because it just won't stop here. If I say there's a derivation, meaning they can change something there, right? And they can ask you questions in advance. Right? So this is the area of a thin strip. Please have a look at this. Ask me any doubts in this page. How did I choose an element? How did I take this? Ask me. Clear? Now we just have to add them, right? Now, can you tell me what are the limits?
0 to theta.
हाँ, यहाँ पे alpha, see what is changing here? Here alpha is changing. When alpha is 0, where are you? When alpha is 0, you are here, na? Center. When alpha is increasing, you took this ring, this ring, this ring. You're adding all these rings. Finally, where do you stop? At the outermost ring, isn't it? Which is theta. Are you getting how you're taking elements? When you change alpha from 0 to theta, you are converting all the rings. Dekho, iska meaning I'll tell you again. If you take alpha 0, you're taking this ring. If you increase alpha little, this ring, this ring, this ring, then this. Eventually, the last corner aayega. That means alpha ka values are changing from 0 to theta. That is the limits. So the surface area will be integral dA, which is integral 2 pi r square sine alpha d alpha 0 to theta. 2 pi r square is constant. Integral sine alpha d alpha from 0 to theta. Sine alpha ka integration is minus cos alpha. Hope you remember that. Limits will go from 0 to theta. So 2 pi r square minus, first put theta, cos theta, then put 0 and subtract them. That's how you take limits. No? Cos theta is cos theta, cos 0 is 1. Huh? Cos 0 is not this thing. 2 pi r square into 1 minus cos theta. Quite an important result. Example, if someone had given you a sphere like this, and let's say this angle is 60 degrees, means you want area only till here. That shaded part ka area would be 2 pi r square into 1 minus theta is 60 here. Cos 60. Cos 60 is off. So that area is pi r square actually. Part of a sphere. So you can actually write the result here. Surface area is 2 pi r square 1 minus cos theta. Remember, theta is half angle, it's not a full angle. That's your result. Please look at the steps. Clear? Please check any doubts on this. Clear? Next one. This is another important shape. Turn the page. I hope all are clear with this. Next one, a paraboloid. A paraboloid is a bowl kind of shape. Okay. Whose equation will look like y is equal to some ax square types. This is a paraboloid. So the equation is y is equal to ax square. Let's say the height of the paraboloid is h and the radius is r. You get an actually pretty interesting result in this. So this is r and this is h. Find the volume of the paraboloid. To find the volume of this shape, it's a solid one. The equation of this is y is equal to x square. Meaning this h equation is y is equal to x square. In case you're getting confused, how does a paraboloid look? You have seen this shape. I'll tell you where. Did you ever see this thing when you take a bucket of water and if you rotate it? Did you see the water forms a cone kind of thing? That shape is called a paraboloid. So whenever you rotate water, that shape which you get, the bowl shape, is actually a paraboloid. Do I have a good diagram here? Give it a try. I'll show you. I'll get you a photo how it looks. I hope the shape was clear, but let me show you how it looks. Answer depends on the h actually, yes. I want the answer in terms of r and h. There, this is a 3D illustration. This shape you see, you must have seen this, when you take a bucket water and if you rotate, put your hand and rotate very fast, you can see that bowl shape. That shape is actually called a paraboloid. So you can clearly see the shape here. It is. So basically, this is a rotating fluid. So that shape which you get when you put your hand and rotate, the water with your hand, the shape which you get, that bowl shape, is actually a paraboloid. So the main idea here is how will you take the elements? Can you just tell me how to take elements? Anyone? How to choose elements? Disks, na? Isn't it? I can take disks. See, I'll help you out. Pi r square h. Nah, that will be full volume, na, Aditya. That will be the full cylinder ka volume. See how we are taking. Take a thin disk. Whose radius is x, whose height is dy. So small height, radius x. So radius x and dy. We did the same thing for that sphere thing also. So the small volume of the thin disk will be pi x square into dy. And what is the equation given? Y is equal to ax square. That is the equation given. So I can replace here x square with pi into pi y a into dy. So I'm just replacing x square with that. X square is y by a. Oh yeah, actually see. So that volume will be integral dv. This will be pi y dy pi a. Y ka value will go from 0 to h because the total height is h. This point y is 0 and this point y is equal to h. If you substitute here, we end up with pi by a y square by 2 limit 0 to h. You get pi h square by 2a. Now, if I just modify this into a bit, you'll get a good result. I'll show you how it looks. So the equation was y is equal to ax square. So this point was 0, 0. This point was r, h. Because this height was h and the radius was r. So when I substitute this in this formula, you get h is equal to a into r square. So a ka value is actually h by r square. And just now we derived the volume is equal to, I'll show you the page, pi h square by 2a. Take a and substitute here, you get pi h square by 2h by r square. You end up with pi r square by 2 into h. You know what you get an answer as? If you take a cylinder of radius r and height h, and inside the cylinder, if you construct a paraboloid, the volume of the paraboloid is half of the volume of the cylinder. That's the best way to remember this thing. Volume of the paraboloid is half of volume of the cylinder it is enclosed. Pretty good result. Are you getting the meaning of this? We proved this, huh? We didn't get it randomly. That means if you look at this volume of the water in a green shade, this is another half of the volume, right? That means the remaining, the green shade will be another half of the volume. So the green shade with the remaining water. The result is more important. And you saw how to take the elements. Please check it out.
Could you show the last page?
Please look at the steps. The result is interesting result. The volume of a paraboloid will be, I'll just write the answer here. 1 by half of pi r square h. The answer will come as if it is half of the volume of that cylinder. Clear? Any doubts on this?
So can you go to the next page?
Next page. Yeah. Please check the steps, and yeah, this result comes next. Quite useful. Volume of the paraboloid is half of the volume of the cylinder it is enclosed. This one, out of all the things that we did today, this is the most important result. Part of a surface area of a shell. This is the most important one. Okay. So there. Well, last one for the day. We'll finish off with areas and volumes today. Next class we'll be doing integration of vectors and integration of acceleration velocity parts, and then I think we are slowly getting into kinematics next. Easy one. Let's say you have a sheet like this. So this is the origin. This is your x-axis. This is your y-axis. And this curve, right, is y is equal to x to the power of 3 by 2. That curve is y is equal to x power 3 by 2. It is symmetry on both the sides. These coordinates are a comma 0. Find the area of the sheet. It is symmetrical on both the sides. Up and down, it is symmetry.
Y to the power x power 3 by 2 will give one side of the graph or both sides of the graph?
This is only the upper side, na? Lower side का क्या होगा? Lower side will be y is equal to minus x power 3 by 2. Got it? So actually, if you can
repeat the question.
find the surface area of the sheet, na, the shape का area कितना होगा? Actually, if you can just find for the upper half, and you can double that, right? Because it is symmetry, you just need to find the area of any one piece and just double it, you'll get the answer. Check it, this is an easy one. Just finish it off. I'll get some water and come. Let's see. 4 by 5. Okay, we got few answers. Let's see. 2a power. We will just take 1/2 of it and we'll finish it off. So this is 0, 0, and this is a, 0. So at a distance x, we take a thin slice. Isn't that how we started integration actually? Whose thickness is dx and the height is y. Isn't that the whole point of integration? We started like that only. So what is the area of that small rectangle? Area of that small rectangle is the height into length, breadth, y dx. And what was y? Y is x power 3 by 2. So that is x power 3 by 2 into dx. So what is the area of this? Integral dA is integral x power 3 by 2 dx. X ka values will go from 0 to a because this point is x is equal to a. So this will be x to the power of 3 by 2 plus 1 by 3 by 2 plus 1. X power 5 by 2 by 5 by 2. So that is 2 by 5. Limit 0 to a. 2 by 5. Substitute a ka value, a power 5 by 2 minus 0. This is 2 by 5, a to the power of 5 by 2. But this is not the answer. Total area will be double of this because there are two strips. So 2 into 2 by 5, a power 5 by 2. Check. You have to double that because there are two strips. Is this clear, everyone? All got this? Easy? There, we did around 6-7 problems, but these are pretty good ones. Shreyansh is totally tired. I can understand. Right? So make sure to go through these things again. Getting it? I'll send you a small sheet based on these kind of questions you can try. Okay, so with this, we'll wrap up for the day. I think last class I sent you some 3 assignment sheets of that doubts and paper ka doubts. I think we will discuss the paper ka whole doubts in the next class. So everyone resolve the paper today, posted it. Have a look at that. Resolve. If you got only 1 or 2 major things, we can see those things also. Okay. So any doubts, please stay back and ask.